The next topic I want to talk about is one called verifying solutions. And derivatives can be used to verify the function. Remember, we have two solutions for a derivative. We have a general solution and we have a particular solution. General solution is where we end up with the antiderivative plus c. And the other one is where we actually know the value of c, and we call that a particular solution. So we had talked about this last chapter, so this is a little bit review. So here I have a derivative. I want to figure out the antiderivative. So I'm going to integrate to figure out the antiderivative. And notice there's no a or b, no boot or hat. And so I'm going to do this one right here. I'm going to do a little bit by substitution. I'm going to say, all right, u is going to be 2x. The derivative of u is going to be 2 dx. That means 1/2 du will replace dx. And I'm just going to do it right here in the margin. So now I have, and I'm looking at this, so I got 1/2 integral of, and I'm just focusing on this, e to the u, and here's dx, 1/2 du. What's noticed about e to the u is itself the u, so this is going to be 1/2 e to the 2x. So I'm going to write that down, 1/2 e to the 2x. And then this is just reversing the power rule. This is going to be x cubed. I added one there. I'm going to multiply by the reciprocal or divide by 3. In both cases, I'm going to get 2/3. And then I have my plus c, and that is what y is equal to. So this was dy dx. This is y. And now it says when I put 0 in for x, y is 4. So over here, I'm going to have a 4. And I'm going to put 0 in for x. I'm going to have 2 times 0 here. That's 0. Minus 2/3 times 0 cubed plus c. Well, this is 4. This is a half. E to the 0 is 1. This is 0, so I have my plus c. So I'm going to subtract a half. I'm going to get 3.5 equals c. So my particular solution for this differential equation, it's a differential equation because it has a derivative, is y equals 1/2 e to the 2x minus 2/3 x cubed plus 3.5. All right. This problem is it's the same. It says a curve has a slope. Well, notice when it has a slope, remember, so this is the slope of the tangent line, and this gives me the slope of the tangent line at each point on the curve. What equation of this curve if it passes through the point 0, 4? Well, what they're saying is your slope, dy dx, is equal to e to the 2x minus 2x squared. And then that means we have a particular solution, y equals 1/2 e to the 2x minus 2/3 x cubed plus 3.5. And when we plug 0 into there, we'll get 4. Because I'll get a half here, I'll get 0 here, I'll get 3.5. So this gives me the slope of any point on this curve. And this curve passes through the point 0, 4. Okay? All right, next. Now I've got the second derivative. So this is the second derivative. Second derivative. And it says when you put 1 into the first derivative, you're going to get 7/6. And when you put 1 into the function, you're going to get 0. And it says find the particular function of y. So we want to come up, what is y equal with if it passes through this point? Well, to get here, I have to get to the first derivative first. So when I take the antiderivative of the second derivative, it will give me the first derivative. So I'm going to write this is, I'm going to write that the first derivative is going to equal the integral. And I'm going to write this as x to the negative 2 power plus 1 minus 2x squared. I'll write dx here. All right, so when I integrate this, y prime will be this antiderivative. So I'm going to add 1. That's going to give me a negative 1. And then I'm going to multiply by a negative 1 because negative 1 is its own reciprocal. So I get x to the negative 1. Now I'm going to do u substitution over here. I'm going to say u is equal to 1 minus 2x. du is equal to a negative 2 dx. I don't have a negative 2, so I'm going to have a negative 1/2. du is going to replace dx. And so then I'm going to have a negative 1/2. The integral will be u squared du. This is going to be u to the third. I'm going to have a 1/3 here times a negative 1/2. So that's going to give me a negative 1/6. So I'm going to have a minus 1/6. And then this is going to be 1 minus, remember u is this, so I'm putting u back in there, 1 minus 2x to the third plus c. Now, I'm going to figure out this c using this information right here. When I plug 1 into this derivative, I'm going to get 7/6. So here I'm going to have 7/6. 1 to the negative 1 power is 1. Multiplied by a negative 1 is negative 1 minus. In here, I'm going to put 1. 2 times 1 is 2. 1 minus 2 is a negative 1. A negative 1 cubed is a negative 1. Times a negative 1/6 is plus 1/6 plus c. So this is going to be 7/6 is equal to, well, this is a negative 6/6, negative 5/6 plus c, which means I got 12/6, which is 2, which is equal to c. All right? So my first derivative now is going to be, all right, this is a negative 1 over x minus 1/6, 1 minus 2x. All I'm doing is rewriting this, and I'm going to put 2 in for c. All right, so now I'm going to figure out the antiderivative of this. And that's going to be the integral of a negative 1 over x minus 1/6, 1 minus 2x cubed plus 2 dx. Well, this is going to be a negative natural log. I'm going to come over and do this again. So I'm going to have u be this. And then I'm going to get this. I'm going to get 1/2 du u. The only difference is I'm going to have a negative 1/2 integral u to the third du, because it's to the third right here. So that's going to give me a negative 1/2 times 1/4 u to the fourth. Okay, but I also have this minus 1/6. So I'm going to have a minus 1/6. This gives me a negative 1/12. Let's see, negative 1/2. be 4, yeah, negative 1/6 times a negative 1/12. I feel like I'm doing something wrong here. Oh, I know what I did wrong. This is a 2. I made it a 3. It's a negative. It's a 2, not a 3. So this can be a negative. This will be a negative 8 times. This will be an 8. That's where I made my mistake. Sorry about that. I'm sure you guys are seeing that too. Yeah, it's going to be an 8. So it's going to be 1 minus 2x to the 4th. And then the antiderivative of 2 is 2x plus c. So now I have to figure out, I got to put this value in. So I'm going to get 0. I have the negative natural log of 1 minus, this is going to be a plus 1 over 48. Now if I put 1 into here, I'm going to get a negative, I'm going to get minus 2, which is a negative 1. Negative 1 to the 4th is a positive 1. Plus 2 times 1 is 2 plus c. All right, what do I get here? This is 0 plus 1 over 48 plus 2 plus c. So this gives me, when I move it over here, a negative 2 and 1/48, which is equal to a negative 97 over 48, which is c. So my y is going to be y equals negative natural log of x minus plus 1 over 48, 1 minus 2x to the 4th, plus 2x minus 97 over 48. And of course, as usual, I did not give myself any room. All right, a little trig remembrance. The derivative of sine is cosine. The antiderivative of sine is negative cosine plus c. Derivative of cosine is negative sine. The antiderivative of cosine is sine of x plus c. And you can take the derivatives and check to see if that's correct. All right, so this is another problem under verification. It says, for what value of k, if any, will y equals k e to the negative 4x minus 2 sine of 5x be a solution to the differential equation of this? Alrighty. I got to figure out k. So what I'm going to do is I'm going to substitute the second derivative, the function in here, and solve. So the first derivative equals, well, the derivative of e the negative 4x is e the negative 4x times the negative 4. So now I got negative 4k. That's the first derivative. Derivative of sine is cosine. And then I got the chain rule of 5. So I'll have 2 cosine 5x 5. That's going to be a minus 10, because 2 times 5 is 10 cosine of 5x. All right, so I got to do this another time, second derivative. And if you notice, I'm going to get e to the negative 4x, but I'm going to times it by another negative 4. So this is going to become 16k e to the negative 4x. And then this is going to be negative sine, but I got a negative, so it's positive. So that's going to be the sine of 5x. And then I'm going to get a 5 from here times that 10, and so it's going to become 50. So that's my second derivative. So it says over here the second derivative right here is this. So I'm going to have 16k e to the negative 4x plus 50 sine of 5x. And now it says plus 25 times y, and this is y up here, which is k e to the negative 4x minus 2 sine of 5x equals a negative 82e to the negative 4x. All right, so I got 16k e to the negative 4x plus 50 sine of 5x plus 25k, I'm distributing now, 25k e to the negative 4x, 25 times 2 is a minus 50. Ooh, I'm happy to see that. Matthew, aren't I happy to see that? 5x equals a negative 82 e to the negative 4x. I have a positive 50 here and negative 50 here, so I got a little bit of death going on. Wonder if I got a red pen. I don't know if this is red. Yeah, it's not a very good pen. So anyway, this and this are gone. And I'm going to have 25k e to the negative 4x, 16k e to the negative 4x, 41k e to the negative 4x equals a negative 82 e to the negative 4x. I can divide this side by 41 and e to the negative 4x, and divide this side by 41 e to the negative 4x. Simplify, 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 and k equals negative 82 divided by 41 and negative 2. Awesome. Q, E, D. All right. Have a nice day. See you tomorrow.